Greetings, everyone. I am Professor Hooks from Arizona State University. Have you ever gotten confused about signals like U of 2 minus N or U of minus N plus 2 or U of minus of N minus 2 in parentheses? It looks simple algebraically, but the order of operations really matters. In this video, I'll show you a step-by-step approach to correctly interpret these signals and avoid common mistakes. Let's start with why are we doing this? A practical example comes from FPGA-based radar signal processing. On the FPGA, we first store the known signal in memory, which is block RAM, creating a short delay. Then we reverse the signal in time, second block RAM, and multiply it with the incoming echo signal. Summing these products over the signal duration produces a sharp correlation peak whenever the incoming signal matches the stored signal, a fundamental operation in real-time signal processing. So what about this unit step function that looks a bit tricky? How do we methodically perform a signal manipulations? These are the kinds of problems you'll see often in homework and exams. The key is to interpret the signal correctly and perform the operations in the right order, so you can get the correct result. Do you shift first or time reverse first? Actually, the order of operations is similar to what we do on the FPGA radar example. We shift first, then we do a time reversal or flip. According to Oppenheim, example 1.1, on pages 10 to 11, the systematic approach is simple. We first shift the signal, that means advance or delay, by beta, and then we apply a time reversal and scaling according to alpha. Following this method ensures you always get the correct result when a signal has multiple manipulations. So when interpreting U of 2 minus N, I first rearrange it to the model that Oppenheim presents on page 11. I start with U of N, the basic unit step function, which is 1 for N greater than equal to 0 and 0 otherwise. I always begin by drawing the basic function. Never just assume you can see it from the equation. According to Oppenheim, the first operation is the shift. The +2 inside the brackets means the signal is advanced by 2, which corresponds to shifting it to the left on the time axis. So the step that originally started at N equals 0 now starts at N equals -2. Next, we apply the time reversal by -N. Flipping the signal across the vertical axis moves the step from -2 to +2 and reverses its orientation. So instead of opening to the right, it now opens to the left. In other words, U of 2 minus N is a step function that turns on at N equals 2 and stays on for all values less than 2, less than or equal to 2. What if I were to interpret u of 2 minus n as being equivalent to u of minus, in parentheses, n minus 2? Algebraically is correct. And what if I were to perform the order of operations from Oppenheim and I delayed the signal by 2 and applied the minus sign to flip it? I would get this result right here. But it's different from what I got before. If I delay and then flip, I am actually performing a different operation. I end up with this, u of minus n minus 2. Although algebraically, it looks like I should be able to do this, in reality, I cannot. I am inferring a different signal, and that is incorrect. You need to carry out your multiplications when you see a signal like this, and then perform the operations according to Oppenheim to get the correct results. I hope this helps you, and I would appreciate it if you could subscribe to my channel and hit the like button, and always, please leave your comments and suggestions. Have a peaceful day. Bye for now.